This is Jack Jackson. This is the first of our series of videos talking about going from the unit circle graphical representation of trigonometric functions to the Cartesian coordinate representation. We're going to be using my sketch here called Trigonometry Ultimate, and the tab that we're going to be using is called Graphing Trig Functions, and so it goes to this page here. And it gives some explanation here that I'll kind of go over, so I'm going to hide that and just talk about it here. So notice that there's a lot of stuff on this page here, but let's take a look and kind of break it down. Over here on the left you'll see a graphical representation that gives you a unit circle. And we have a point on the unit circle that we can move around. That point we'll call P has coordinates x and y. And recall that the x-coordinate of that point is the cosine of the angle, the y is the sine of the angle, and y over x is the tangent of the angle. Now, remember that the angle is the same as the arc length, or the distance this point travels as we start here in standard position at the initial ray and spin it here. So, for example, in this first quadrant angle, this pink distance here is our arc length S, which is also the radian measure of that angle. Now, that's in the picture over here. We're going to come up with a new picture over here to the right, and notice I have this very carefully constructed so that the scale is the same. So it's 1 unit from the center out to anywhere on this circle. This is the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1 on the unit circle. But I have the same distance as 0 to 1 on this Cartesian coordinate system over here on the right. So a distance from 1 would go out to this green dot right here from the origin, or from the origin up to 1, or from the origin down to negative 1. However, over here I've got the x-axis labeled off not in, say, 1, 2, 3, 4 like I do the y-axis. In fact, the y-axis is marked off in halves. There's a half, 1, 1 and a half, 2. But this one is marked off in multiples of pi over 12. So you got pi over 12, 2 pi over 12 is pi over 6, 3 pi over 12 is pi over 4, 4 pi over 12 is pi over 3, 5 pi over 12, 6 pi over 12 is pi over 2, and so forth. And then, of course, negatives going this way. Now what I want you to notice is the connection between these two pictures, and whether we're doing sine, cosine, or tangent, or secant, cosecant, or cotangent, the connection is going to be that this radian measure of this angle, the amount of rotation over here, so it's an actual angle over here in the left picture, is actually an x value here, or basically a horizontal length here. And so notice as we pull this point, as we spin the point around, look at the picture on the left, it's spinning around here, and for now it's just going to go between 0 and 2 pi, but we know that we could also spin in the negative direction, and we could spin around more than once and the values would repeat. But you can see the pink illustrated going from 0 to 2 pi. Now as I do that same thing again, watch this yellow dot on the graph on the right. Notice that as it goes here, it's tracing out, and it goes from 0 up to 2 pi. Okay, and of course if we would spin around, this dot would continue on out to the right. In this particular sketch it's going to start over again, but you can kind of see that it would continue on. If we spin in the other direction, this unshaded region would be how far the dot should go to the left here if we're spinning that way. So we can see this point moving here. So notice that what is an angle in the picture on the left, the unit circle picture, is a x value, or horizontal distance, sine distance, on the right. Now let's see how we can see sine. So I'm going to click on the Show Sine button. Now remember, over here in the right, the sine is the y value of this ordered pair of this point P as we move it around. And so it's this vertical distance here, the y. Well, if we want to graph over here on the right the function y equals sine of x, so the input x over here on the right is not the same as the x over here on the left. The input x here is your theta, or your t value, I call it theta in this case, the angle value, or s or theta, which is this arc length or this angle measure. So on the left, the input is s or theta, which is the angle measurement, which is right now at 0.78 radians. Okay, and that means that we're at 0.78 for x here. Okay, which is pretty close to pi over 4. There. Okay, now what we want over here is the y value on this point right here in the first quadrant there in the Cartesian coordinate system to be the same as the y value over here. So notice I've drawn a horizontal line. You can see this dotted red line right here going across, and it keeps the y value the same. So now let's look at what happens here. Just look at the unit circle picture for a minute. As the sine is the y value, so when we start here it starts at 0. Then as I go up this way it gets bigger, and it works its way up to 1 for angles that go between 0 and pi over 2. They are y values, sine values, between 0 and 1. When we get to pi over 2 for the angle, we get at a y value of positive 1. Then as the angle continues around here to be an obtuse angle, something between pi over 2 and pi, we work our way down from 1 back down to 0. So still positive values, but now decreasing down to 0. Once we get into the third quadrant, now we're looking at negative values for y, and so our point is below the axis over here on the Cartesian coordinate system. And so it works its way from 0. So again, let's go over this again. So first quadrant, so the axial angle here, the sine is 0. First quadrant angles working their way from 0 down up to 1. Then second quadrant angles working from 1 down to 0, which is what happens when you get to pi for theta. And then from there, what are we doing? We're going up, we're going down some more into the negatives. So now we work our way down from 0. These third quadrants are negative for sine, and they work our way from 0 down to, well, into negative 1 when we get right here at 3 pi over 2. And then as we go from 3 pi over 2 to 2 pi, we're increasing, still negative, but working our way up from negative 1 up to 0. Okay, so now let's watch the point, the yellow point over here, not the yellow point, the red point. Let's watch the red dot over here on the graph on the right. As I go around, once again, what is it doing? It's starting at 0, works its way up to 1, turns around and comes back down, goes down and hits 0 at pi, keeps going down, hits negative 1 when x is 3 pi over 2, and it goes back up to 0 and it hits 0 when x is 2 pi. Okay, and so this is tracing out a graph as we go around. So let's see what graph that's tracing. Well, this is what the graph looks like, and you can see it actually tracing out what we call one period of this graph. So remember, we talked earlier about this fact that this function is what's called a periodic function. So if we go around 2 pi, from 0 to 2 pi, we get one complete cycle of this wave over here. If we spin around again, look what's going to happen. It's going to repeat the same y values in the next part of the wave, going from 2 pi to 4 pi. Well, what if we go in the negative direction? Then we're over in this part of the graph, and it's repeating the same values over again, like this part of the graph right here, back this way. So in fact, this is a wave that goes on forever. Okay, so if I go over here and look at this, let's see, let's put the grid on here, and let me put A. I want A to be 1. Actually, you know what? I'll go to the next one. If we go here, if A is 1, B is 1, H and K are 0, we'll talk about what those things mean later. But basically, this is your basic sine wave here. And notice it goes over and over. This wave is going over and over and over and over and over again, infinitely many times. So there are infinitely many maxima, infinitely many minima, infinitely many inflection points, which is also turns out to be where it crosses the x-axis. And we get this. So this is what we have as a periodic function. We see this is this wave is going around here. So this is just y equals sine of x is what we have right here. So there's an introduction to sine of x. Now let's go back, let's review here. How does the picture on the left and the picture on the right, how do they connect to each other? They're two different representations of the same function. Over here, the input is the arc length, or the radian measure of this angle, which is this pink arc length. The corresponding length, the exact same length, is over here in pink here. So if we were to take a piece of string or a tape measure, let's say, and go along this path and measure that arc length, and then straighten it out, we would be measuring exactly the same length to here. Okay? What about the y value here? Well, the y values are the same, so they're at those 2 points are at the same height as we go around. And of course, this being a circle, every time you make it all the way around the circle, the whole pattern starts over again, and so this little wave thing continues over and over and over again, repeating itself every time we go over a distance of 2 pi. Okay, we're going to come back in the next video and do the same thing for cosine. In the following video, we'll do it for tangent.